In part 3 of this lesson, we're asked to separate the expression 2 over s to the power of 3 bracket 3s minus 2 into partial fractions. This problem is similar to that we faced in question 2. Here we have the linear factor 3s minus 2 and the repeated linear factor s to the power of 2, and s to the power of 3. So in this case, what we will do is rewrite this s to the power of 3 bracket 3s minus 2 and make that equal to each of the factors as their own fraction. So starting with 3s minus 2, we will create a fraction for this where that's the denominator, plus s to the power of 2 plus s to the power of 3. And we'll introduce an unknown in the numerator position of each of these. So I'll call the unknown here a, b, c, and d. Notice that each of these unknowns represents a number. And the reason why is we want to create proper fractions for each of the factors. And by having just a number, that makes it a proper fraction because in the denominator position, we have a letter with the degree 1. So the only way to make it proper is to have numbers. So how do we find a, b, c, and d? What I'll do next is combine all 4 of these fractions together. And to combine fractions, you need a common denominator. To find a common denominator, you multiply all the denominators out. And by multiplying these denominators out, we should get what we started with. Once you have your common denominator, you'll multiply each of the numerators by that common denominator. Here's what happens when you do that. Let's say we multiply a by this expression. We'll end up with a times s to the power of 3. Why? Because 3s minus 2 cancels out with 3s minus 2, leaving us only with s to the power of 3. Let's do the same thing for this fraction. Let's multiply this expression by b. I'm going to give you a second to think about this. What will happen to this fraction? If you thought of the following, you are right. You should end up with b s to the power of 2, 3s minus 2. Because this time only this s and one of these s's cancel out. Let's try the next one. We should end up with c s bracket 3s minus 2. 2 of the s's cancel out with 3 of these, leaving us with 1. And lastly, we have plus d bracket 3s minus 2 all over our common denominator of s to the power of 3, 3s minus 2, and on the left side we have 2 over s to the power of 3, 3s minus 2. Now because the denominators are the same on both the left and the right side, we can discard those. We don't have to worry about them, leaving us with 2 is equal to everything in the numerator here. Now that we have this set up, we have to find our a, b, c, and d. To do this, we'll have to expand everything on the right side. And that's going to take a while, so let's begin with this. We have a s to the power of 3, that doesn't change. This expands, where we get b times s to the power of 2, 3s minus 2, b times s to the power of 2. This one becomes c times s, 3s minus 2cs, and this one becomes plus d 3s minus 2d. I'm going to clean this up because it's messy right now. This will stay the way it is. A s to the power of 3. This becomes 3b s to the power of 3. These are like terms. We'll discuss that later. That remains the way it is. Plus 3c s to the power of 2 minus 2c times s plus 3d times s minus 2d. Alright, let's collect like terms. All the s to the power of 3 terms are alike. So this is alike with this. This is alike with this. These two are alike. And remember, we did this in question 2 with this. And since this one doesn't have an s, and this one doesn't either, we set those two alike. So starting with what I underlined in green, I have 2 is equal to negative 2d. I can easily find my d just by dividing both sides by negative 2. My next equation will be those highlighted in green. We have 0 on the left side, negative 2c plus 3d. My next equation will be those in blue. We have 0 on the left side, negative 2b, and here we have plus 3c. And finally, we have 0 is equal to a plus 3b. Okay, let's go ahead and find out what d is equal to. D is equal to negative 1. I'm going to place negative 1 into here. That gives me a negative 3. Bringing that 3 over to the left side and then dividing both sides by negative 2 gives us c is equal to negative 1.5 or 3 over 2. Negative 3 over 2. Now we can substitute c into here to find b. So if I substitute negative 1.5 into here, that gives me negative 4.5. Bringing negative 4.5 to the other side makes it positive 4.5 divided by 2. So we have b is equal to positive 4.5 over negative 2. That's equal to negative 9 over 4. And lastly, we have to find a. And the way we do that is replace negative 9 over 4 into here. It gives us 27 over 4. Bringing negative 27 over 4 to the other side makes it positive. Therefore, we have 27 over 4 as our a value. That being said, I'm going to take these numbers and place them where they belong, here. So by placing what I just found for a, which was 27 over 4 into here, makes this 27 and 4 at the bottom. Placing negative 9 over 4 into b makes this 9 over 4, and this becomes minus. Placing negative 3 over 2 into c makes this 3, this 2, and this negative. And lastly, placing what we found for d, which was negative 1, into here makes this negative 1, giving us the following as the partial fraction version of 2 over s to the power of 3 bracket 3s minus 2. And there you have it. That is how to separate fractions into partial fractions. If you want another complicated example, make sure to watch question 4. The more examples that you do, the better you'll be doing these on a test. See you soon.